All right, today we will be talking about force and motion. All right, so forces can create changes in motion. They can cause an acceleration or deceleration, right? Speeding up or slowing down. So, definition of a force, you have a force is a push or a pull. So, a balanced force is a force that produces no change because it's balanced by equal yet opposite forces. All right, so balanced forces are forces that result in the object motion being changed. So if it's unbalanced, right, you're going to have more force going in one direction than the other, causing an acceleration or deceleration. Motion can be described as a change in an object's position due to like a reference point. So like if you have a reference point, you're looking at a point like on the wall and something moves, that would be motion that occurred. All right, so Newton's first law of motion. All right, so the first law states that an object at rest will remain at rest, and an object in motion will remain in motion unless an outside force acts on it. And then friction's an example of an outside force. This law is also called the law of inertia. So an example of that. This explains why you fly forward in a car when someone slams on the brakes. Because of inertia, your body wants to keep moving at the same speed as the car. So when you're sitting in the car, you're actually traveling the speed of the car. So when you slam on the brakes, you're still going, let's say 45 miles an hour. You slam on the brakes, your body was going 45. That's why you go forward, right? And then that's why you wear a safety belt and you have airbags to, save your life and not die, because that'd be terrible. Recap time. First one, we love it. Here it is. What is Newton's first law of motion? And provide a real life example of this law in action, not using my previous crash dummy example. Newton's second law of motion. So this is the most forgotten law for some reason. The second law states that a force on an object will move the object in the direction of the force. So the relationship between force, mass, and acceleration is summarized by the formula F, force, equals ma, which is mass times acceleration. So this law explains why a golf ball will roll in the direction of a force applied to it. So if you have a force exerted on an object, based on how much mass it has, determines the acceleration needed to determine the force. So let's look at an example. So the question here, we have a frog leaps from its resting position at the lake's bank onto a lily pad. We all love frogs. We dissected them. If the frog has a mass of 0.5 kilograms and the acceleration of the leap is 3 meters per second squared, because we do acceleration in meters per second squared, not just speed, which is meters per second. What is the force that the frog exerts on the lake's bank when leaping? So we're solving for force. So the formula chart says that F, force, equals mass times acceleration, m times a. So m is mass in kilograms and acceleration is meters per second squared. So solving that, you take your mass, 0.5, take your acceleration is 3 times 0.5 is, you guessed it, C, 1.5 newtons of force that frog exerts on the lake bank. Recap time, second one, here we are, we love it. What is Newton's second law of motion? And provide an example, not my frog. Newton's third law of motion. So the third law states that for every action, there is an equal but opposite action. So example, a skater pushes back on the skates, but the skater moves forward. So you're pushing back and that moves you forward. And then those three laws in summary, they explain all the laws of motion. All right, so question, the hands of a swimmer pushing backward against water represent an action force. What is the reaction force? So the action is the hands pushing back. What's the reaction? A, the swimmer's body moving forward. B, the water pushing against the swimmer's hands. C, the swimmer's body pushing against the water. Or D, the water moving backward from the swimmer. Go ahead and answer that in your journal. Recap time, third one, here we are. What is Newton's third law of motion? And provide an example of the third law of action and reaction. All right, just to recap on friction, we mentioned it earlier, just wanted to make sure we knew, as we see that polar bear not watching out for the ice as the sign reads, a force that opposes or works against the motion of two objects that are touching. So friction causes an object to slow down and eventually stop. Since the amount of energy stays constant, the energy becomes heat, right? Because right? Friction and creates heat. Last thing here, universal law of gravity. So this states that all objects in the universe attract each other by the force of gravity. Gravity varies depending on these two factors, and you should have learned this in sixth grade, but let's go over it again just in case we fell asleep during sixth grade. The mass of an object doing the pulling and the distance from the center of the object. So the closer an object is to something and the more mass it has, will exert more amounts of gravity. That's why something like Jupiter, for instance, very large planet, has 79 moons. Well, it's because it's massive. It's humongous, right? So because it's so large, has a lot of mass, those objects are close to it. That's why it has so many moons. Whereas us, Earth, we're very small as in comparison to Jupiter. So we were only able to attract one moon. We just have our moon set times. So on Earth, our gravity is 9.8 meters per second per second. And that's the force pulling on us. For every second an object falls, its speed increases by 9.8 meters per second. Pretty cool to think about. Final recap time. Fourth one, final. Here we are. What is friction and how does this impact Newton's first law of motion, which is inertia? And then also explain the universal law of gravity and what two things affect that. Thank you for watching.